Professor Robert Ellis had spent years studying old navigation records, but one sentence in a weather trained journal stopped him cold. We know the stars, we know the moon, but where are we? Robert read it again. The question had been written by a navigator at sea centuries ago, when the horizon offered no landmark and the ocean could stretch for days in every direction. No GPS, no radio, no satellite, no screen displaying a blinking position, just a wooden ship beneath an enormous sky. And yet, somehow, these sailors could determine where they were. Robert wanted to know how. He began with the obvious question: how do you find your position when you cannot see land? Latitude was comparatively manageable. The height of the sun or known star above the horizon could provide a clue to north south position. Longitude was the difficult part. To determine east west position, a navigator needed an accurate comparison between local time and the time at a known reference location. That means time. Robert smiled. He had started with navigation. He had stumbled back into his favorite subject, time. Then he found the method that fascinated him most. It was called lunar distant navigation. The principle sounded almost impossible. A navigator could measure the apparent angular distance between moon and a known star, or sometimes the sun, using an instrument such as sextant. The moon was constantly moving against the background of the stars. That movement was predictable, and if its position could be measured accurately enough, the observation could be compared with astronomical tables calculated for a known time. The moon had become a kind of celestial clock. Robert looked up from the book. Not a clock you could carry, a clock you could look at. He decided to reconstruct the calculation himself. Robert spread navigation tables across the desk. Then he drew a circle, the earth. He marked 2 points, one representing the ship and the other representing a reference meridian. The earth rotates approximately 15 degrees of longitude every hour. So, a difference in time corresponds to the difference in longitude. The principle was simple. The execution was anything but. A navigator had to measure the moon's position precisely, then account for atmospheric refraction, then account for parallax, then connect the observation using astronomical tables, and then calculate the corresponding time, and finally convert that difference into longitude. Robert stared at the calculations. The sailor wasn't really measuring the distance to the moon. He was measuring an angle, then turning that angle into time, and turning that time into a position on Earth. The moon had become a ruler, not a ruler made of wood or metal, a ruler made of geometry. A few weeks later, Robert went aboard a small research vessel to try the observation himself. The moon was bright, the sea wasn't. The vessel rose and dropped with every swell. Robert lifted the sextant. He tried to bring the moon's lower edge into alignment with the distant star. The image shook. He adjusted. The ship rolled. He lost it. He tried again. For several minutes, he understood the problem in a way no textbook can ever allowed him to. This was not simply astronomy. It was astronomy performed on a moving planet from a moving ship by a moving human hand. He finally captured the measurement. It was only one observation, but it was enough to make him pause. Generations of navigators had done this under far more difficult conditions. They had stood on decks in darkness, wind, and cold, carrying instruments that demanded extraordinary patience. They had trusted calculations rather than electronic signals. And above them was the same moon. Robert returned to his cabin and completed the corrections. The numbers slowly converged. He checked them, then checked them again. Finally, he looked at the calculated longitude. It too was not perfect, but it was remarkably close. Robert walked back to the deck. The moon hung above the black horizon. It looked impossibly distant, yet its movement has just helped him locate himself on Earth. He thought about the old navigator's question, where are we? Perhaps that had always been one of humanity's great questions. Where am I? Where am I going? How far have I traveled? How do I get home? For centuries, people had looked upward to answer questions about the world beneath their feet. The stars provided direction, the sun provided rhythm, and the moon provided a moving reference against which time could be measured. Robert closed the navigation book. We never need to touch the moon, we only need to understand it. He looked towards the horizon. The ship continued forward. The moon continued its silent journey. And somewhere between the two, mathematics has turned something impossibly far away into a guide. Sometimes exploration isn't about reaching the thing you see in distant. Sometimes it is about learning how to use it to find your way. If you enjoy these journeys into the hidden ideas that help people understand and navigate our world, stay with us and consider subscribing because there is always another mystery above the horizon.